Hello and welcome to this video on integration. Okay, so we already have met differentiation, so we know that y, if we differentiate it, we get dy by dx. Okay, so integration is the opposite of differentiation, undifferentiating. So if we integrate dy by dx, we get y. Okay, so if we get a question like this, basically this is asking us what could we have differentiated to get this. Okay, so let's do it term by term. So this has got an x squared. So when we differentiate, we take one from the power. So when we integrate, we're going to add one. So it's definitely going to have an x cubed. And then the 4 is going to stay there. And then let's think about it. So if we differentiated x cubed, we'd get 3x squared. And we want 4x squared. So that 4 stays there. And we write this. So this is the notation we use. We write the 4, the number that was already there, then we do some brackets, and we do 1 over whatever this power is, and then x to the new power. Okay, so y equals, that's our first term. That's some working, so we won't worry about that. Okay, plus 2, and then we do the brackets. So this was x to the half. So now we're going to have x to the 3 over 2, because we've added 1 to the power. Okay, so then we're going to have to divide by 3 over 2, so that's the same as timesing by 2 over 3. And then this 3. Okay, what could we have differentiated to get a 3? Okay, so that's the same as kind of 3x to the 0. So then we write this as 3, and then do the brackets, and then x to the 1. And because this is 1, we've got 1 over 1 in the brackets, so we don't need to worry about it. Okay, one more essential thing. What would happen if we had a plus 7 here? It would, when we differentiate it, it would disappear. So we don't know if there was any constant. Okay, and well, we don't know it was 7, but what we write plus c to show we know that there could be a constant without any x's in it. Now, a lot of students forget this in the exam, so basically, don't forget your plus c. You will hear that a lot. Okay, and now we'll just tidy that up to write our final answer. We've got y equals 4 over 3 x cubed plus 4 over 3 x to the 3 over 2 plus 3x plus c. And that's our final answer. Okay, now the notation. So this is how we write integrate these together. Alright, got the pen. These together mean integrate whatever's in here with respect to x. That means, well, if we've got x's here, then we're going to have an x here. So integrate with respect to x, and so that's exactly the same question as before, and so we get exactly the same answer. When we integrate this, we get 4 over 3 x cubed plus 4 over 3 x to the 3 over 2 plus 3x plus c. Okay, last thing is finding c. So sometimes they give us what we call boundary conditions, so they give us an x value and a y value that go together. We can then substitute this into our expression that we found for y, that we got from integrating this, and then we can use this to find c. So here we'd say, substitute in y equals 4, and then x is 1, so we've got 4 over 3 plus 4 over 3 plus 3 plus c. Okay, so this is going to be, that's 8 over 3 plus 9 over 3 plus c. So that's 17 over 3 plus c, which is 12 over 3 minus 17 over 3 is c. And these numbers are horrible because I made this question up. Usually in the exam they're nicer, so that's minus 5 over 3. So now we know what c is, we can write a full expression for y. So we write y equals 4 over 3 x cubed plus 4 over 3 x to the 3 over 2 plus 3x plus, oh no, not, it's because our c is negative, so we've got minus 5 over 3. And that's our final answer for y. Okay, so now have a go at these integration questions. So you're integrating each thing with respect to x. So basically for the first one, so for a, you're doing integral of x squared with respect to x. Have a go, pause the video, and the answers are coming up soon. Okay, now you can check your answers. Here they are, and don't forget your plus c. That will lose you at least a mark in the exam. Plus c, plus c, plus c, plus c.